In this video, we're going to introduce oxidation-reduction reactions. You might also see or hear these called redox reactions. It's the same thing, it's just a shorter name. The basic gist of this is electrons are moving between atoms. So in this diagram we have on the right, here's atom A and atom B, and then notice there is an electron moving from A to B. This is the symbol we use for electrons. It's just a lowercase e with a minus sign in sort of the superscript location. So two things are happening here simultaneously. Number one, we have something that is being reduced. We call that reduction. A reduction is a gain of electrons. So when something is being reduced, it is becoming more negative because it is taking on that negative charge. So in this case, we could say that atom B, whatever it may be, is being reduced because it is accepting that electron. Oxidation, on the other hand, is a loss of electrons. So because it is losing that negative charge, it is becoming more positive. So in this case, atom A, whatever it may be, is being oxidized because it is giving away electrons, so it is becoming more negative. One easy way to remember this is this acronym oil rig. So for oil, oxidation is loss, and of course we're talking about a loss of electrons. And then rig, reduction is gain. So oxidation is a loss of electrons, reduction is a gain of electrons. So here's an actual example down here at the bottom. We have sodium and chlorine, and they are reacting to produce NaCl, which is just the formula for table salt. So we started out with neutral atoms, so they don't have any charge associated with them. So sodium has no charge and chlorine has no charge. But then they have to do something. They have to donate and accept electrons so that they have opposite charges. Because think about it, opposites will attract. So in this case, sodium, because it is in that first column of the periodic table, it likes to donate electrons. So it likes to become a positive 1 charge. Chlorine, on the other hand, which is one of our halogens, likes to accept an electron, so it becomes more negative. So sodium, in this case, has been oxidized, while chlorine has been reduced. And you see that electron going from sodium to chlorine. We can write these out using half reactions. I'll go ahead and show you the reduced one first. So we say that chlorine was reduced because it accepted that electron. So the way we write that out is we have a neutral chlorine, we add an electron, and it becomes chlorine minus. So notice if we had added 2 electrons, for example, we would have had a coefficient in front of that electron showing 2. But in this case, we're just accepting 1 electron to become a -1. We also said that sodium was being oxidized, so it is giving away electron. So you might instinctively want to write sodium minus an electron will give you a sodium with a positive charge, but we cannot have chemical equations with minus signs. So the way we do that, just think about algebra. You add the electron to the right side, so it cancels out on the left. So what we have instead is we start with the neutral charge, and then we go to sodium with a positive charge plus that electron that it is giving away. So that is how you write the oxidize. So just remember you don't have minus signs in those half reactions, so you have to add that electron to the other side so you don't have a negative sign.